In question number 7, a particle projected from the ground passes through a point P whose coordinates with respect to point of projection is 6 meter, 8 meter. If the speed of projection u is minimum, then find the value of u square upon g. Suppose it is given that, let's analyze the situation. Suppose this is ground and a particle is projected from this with some velocity u and with some angle let alpha, and this is the let trajectory of this particle. So it is given in the question that the particle passes through a point 6, 8 meter and the u is minimum. So suppose if I consider, let this is the incline and this incline makes an angle theta, and this separation is the maximum range on the incline if this particle is projected in this way. So I know that if this is R maximum, then R maximum in case of u minimum can be written as R maximum is equal to u minimum square divided by g into 1 plus sine theta, where theta is the angle made by the incline with the ground. So if I substitute the value of R maximum, because this point coordinate is given as 6, 8, so I can find out this R maximum is 10. So 10 is equal to u minimum square divided by g into 1 plus sine theta. So I can easily calculate this angle because these coordinates are known. So sine theta is equal to perpendicular 8 divided by hypotenuse, and hypotenuse is 10. So it comes out to be 4 by 5. So if I substitute the value of sine theta, so I can find out from here u square minimum divided by g comes out to be 10 into 9 by 5. So on solving, it comes out to be 18. So the correct answer for question number 7 is 18. Let's move to question number 8. In question number 8, a particle moves in the xy plane according to law x equal to 8t square and y is equal to 16t, where t is in seconds. Find the radius of curvature of the trajectory in meter at t equal to 0. So we have to calculate the radius of the trajectory at t equal to 0. So let's analyze the situation. Suppose this is the particle. So if I consider the velocity of particle in x direction, Vx, then the value of Vx comes out to be 16t. And if I calculate Ax, then it comes out to be 16. Similarly, if the velocity of particle in y direction is Vy, then Vy can be calculated as 16. And if I calculate Ay, then it is to be 0. So now the question is, at t equal to 0, I have to calculate the radius of curvature of the trajectory. So at t equal to 0, the velocity in vertical direction is 16 and the acceleration in vertical direction is 0. At t equal to 0, the velocity in horizontal direction is 0 and the acceleration in x direction, Ax, is 16. So at this moment, the net velocity is in this direction. So if I write the radius of curvature, then radius of curvature is equal to v square, that is 16 square, divided by the component of acceleration perpendicular to the net velocity. So the component of acceleration perpendicular to net velocity in this direction is 16. So it is 16 meter. So the correct answer for question number 8 is 16. Let's move to question number 9. In question number 9, two identical elastic cords of negligible relaxed lengths are tied at one of their ends to fixed nails A and B. The other ends of the string are tied to a small ball of mass 1 kg placed at 6, 8 as shown. If the balls remain at fixed distance of 10 meter from the point O after it has given a velocity 20 meter per second, then force constant of the cords in Newton per meter is x. We have to find out the value of 6x. So it is given that the point P is at a distance of 10 meter from point O. So elastic force is acting in this direction on the particle as well as in this direction of the particle. If I apply the triangle law of vector addition, then I can say that PB vector plus BO vector is equal to PO vector. In the same fashion, if I write PA vector plus AO vector is equal to PO vector. So if I add these two equations, then I can see that PA vector plus PB vector comes out to be 2 times PO vector, because these two vectors are in opposite direction and of equal length, because this separation are equal, so they get cancelled out on addition. So if I see that if I multiply this equation by constant of the string, let k, then k into PA vector plus PB vector represents the net elastic force acting on the particle. So the net elastic force acting on the particle, F net, is equal to k times PA vector plus PB vector, and this is equal to 2 times k into PO vector. And if I write the magnitude, so 2 times k into PO is the net force acting on the particle P, and which always passes through point O. So this is moving in a circle, and the required centripetal force to move in a circle is provided by the net elastic force acting on the small ball. So it is equal to m into v square by L. So if I substitute the data, so 2 into k into PO, that is 10, is equal to mass, that is 1, into velocity, that is 20 into 20, divided by length, again it is 10. So if I solve this, the value of k comes out to be 2. So from here we can say that the value of 6k is equal to 12. So the correct answer for question number 9 is 12. Let's move to question number 10. In question number 10, for the system shown in figure, coefficient of friction between block A and surface is 0.2. Block A is given velocity V0 is equal to 90 under root 6 minus 2 meter per second at t equal to 0. Time in second after which block A comes back to its original position will be. So at t equal to 0, if we analyze the situation, the block A is given velocity V0 in this direction. So due to this, the friction on this block acts in this direction, and gravitational force on block B is acting vertically downward. So the net acceleration is in this direction. So if I calculate the net acceleration A1 at that moment, so it would be mg plus mu into mg divided by 2m. So if I solve this, so it comes out to be 6 meter per second square. So V0 is given in this direction. So suppose maximum distance it moves in this direction is this s, and at this point, suppose from here to here it is time t1, the velocity becomes 0. So we can calculate this time t1 as V0 divided by acceleration a1. From here to here, the distance covered s is equal to V0 square upon 2a1. Now I have to calculate the time from here to here. So as the block gains velocity in backward direction, the direction of friction on block A changes. So I can write the acceleration at that moment would be mg minus mu mg divided by 2m, and on solving this it comes out to be 4 meter per second square. Similarly, if I calculate the time taken from here to here, then I can write half into a2 into t2 ka square must be equal to this separation s, and this is equal to v0 square upon 2a1. So on solving, the value of t2 comes out to be v0 under root a1 a2. So the total time t is equal to t1 plus t2, and on solving this it comes out to be v0 upon a1 under root a2 into under root A1 plus under root A2. So on substituting the value of V0, A1 and A2, we will get the value of T, and T comes out to be, the value of V0 is 90 into under root 6 minus 2 divided by A1, that is 6, and under root of A2, that is 2, into under root A1, that is under root 6 plus 2. So on solving this, it comes out to be 15. So the correct answer for question number 10 is 15. Let's move to question number 11. In question number 11, two blocks A and B of mass 2m and m are connected by a string passing over a pulley. If the wedge is fixed and smooth and blocks are allowed to move, then find time in second after which A and B will be on same horizontal level. And it is given in the question, the value of h is 56 by 15 meter and g is equal to 10 meter per second square. So at t equal to 0, when we release the blocks, then the mass of block A is higher, so the system will move in this direction. So if I calculate the acceleration, then 2m into g sine 37 degree is acting in this direction, and mg into sine 53 degree is acting in this direction. So if I calculate the acceleration A, that would be 2mg into sine 37 degree, 3 by 5 minus mg into sine 53 degree, that is 4 by 5 divided by total mass of system, that is 3m. So if I calculate this, it comes out to be 2g by 15. Now I have to calculate the time in which A and B will be on same horizontal level. So in order to calculate this time, I have to calculate what is the relative acceleration of A and B in vertical direction. So if I calculate the relative acceleration of A and B in vertical direction, then A is moving in this direction and this angle is given 37 degree. So this angle is also 37 degree. So in this direction, the component will be A sine 37 degree. So A sine 37 degree, that is the acceleration of A in vertical direction. And if I see B is moving in this direction and this angle is 53 degree. So the component in this direction is A sine 53 degree. So if I take the relative acceleration, then it would be plus sine 53 degree, that is the relative acceleration in vertical direction. So half into A into t square, that is the distance they have to cover in vertical direction, and it is given as h. So if I calculate t from here, then half into A, the value of A we have already calculated, that is 2g by 15. So if I substitute the value of sine 37 degree, that is 3 by 5 plus sine 53 degree, 4 by 5 into t square is equal to h, and the value of h is given in the question, that is 56 by 50. So if I solve for t, the value of t comes out to be 2 seconds. So the correct answer for question number 11 is 02. Let's move to question number 12. In question number 12, a point source of light S is at a distance L from a screen AB as shown. An opaque object with a height h is equal to L by 8 moves translationally at constant speed v is equal to 24 meter per second from source to screen along a straight line SA. Find the velocity in meter per second of point B of shadow when object is at a distance L by 2 from the screen. So let at any time t, this object is at a distance x from the source. Then applying the condition of similar triangle, we can say that h by x is equal to, suppose at that moment this distance AB is let y, so y divided by L. So from here we can say that y is equal to HL by x. So if I differentiate this equation, dy by dt represent the velocity of point B on the screen, and it is equal to HL into minus 1 upon x square into dx by dt represent the velocity of the object that is moving translationally. and it is V. So if I calculate the value of dy by dt at x equal to L by 2. So it is given in the question that the value of h is L by 8 into L, minus sign is here, divided by x square, that is L by 2 ka square. So L square, and here it is 4, and the value of V is 24. So if I solve this, it comes out to be minus 12 meter per second. So negative sign represents that the point V is moving in this direction and Y is decreasing with respect to time. So the correct answer for question number 12 is 12. Let's move to question number 13. In question number 13, the laws of pressure when a fluid flows through a pipe of diameter d and length L is given by delta P is equal to K times eta into rho raised to the power A into L, V raised to the power B, and D raised to the power C, where eta is coefficient of viscosity, V is velocity, and rho is mass density. This is rho because it is mass density, as we have already said that laws of pressure is delta P. So rho is mass density and K is dimensionless proportionality constant. Then we have to calculate the value of 5 into A plus B minus C. So if I write the dimension of pressure, that is M1 L minus 1 T minus 2, and this is proportional to the dimension of viscosity is M1 L minus 1 T minus 1 into density. So the dimension of density is mass per unit volume. So M into L minus 3 raised to the power A into L. So that is L into V. So the dimension of velocity is meter per second. So L into T minus 1 raised to the power B into D. D is the diameter. So that is L raised to the power C. So if I compare the powers of M, L and T on both sides and solve, then the value of A comes out to be 0, value of B comes out to be 1, and the value of C comes out to be minus 2. So in the given question, we have to calculate the value of 5 into A plus B minus C, and it comes out to be 5 into 0 plus 1 minus of minus 2, that is plus 2. So it comes out to be 15. So the correct answer for question number 13 is 15. Let's move to question number 14. In question number 14, for the system shown in figure, if block A is given velocity V0 is equal to 10 meter per second towards right, then velocity of B in meter per second will be. So it is given in the question, the value of V0 is 10, and at this moment, let theta is the angle with the horizontal, then I can calculate this tan theta. Tan theta is equal to h divided by 3h by 4. So it comes out to be 4 by 3. So from here, I can calculate the value of theta, and it comes out to be 53 degree. So if I take the component of V0 along the length of the string, then this component will be V0 into cos theta. Suppose at that moment the velocity of block B in vertical direction is VB, then from the constraint relationship along the length of string, we can say that 2 times VB is equal to V0 into cos theta. Now I have to calculate the value of VB. So VB is equal to V0, that is 10, into cos 53 degree. So the value of cos 53 degree is 3 by 5 divided by 2. So it comes out to be 3 meter per second. So correct answer for question number 14 is 03. Let's move to question number 15.